Hello students, in last session our exercise 6.4 completed. Now we discuss Pythagoras theorem, the topic 6.6 on page number 144, in which first is theorem 6.7. The statement of theorem 6.7 given on a page number 145 in your textbook. See the statement first. If a perpendicular is drawn from the vertex of the right triangle, vertex of the right angle of a right triangle to the hypotenuse on both sides. The perpendicular are similar to the whole triangle and to each other. The first of all, see the statement. The statement says that if a perpendicular is drawn from the vertex of the right triangle, the first of all we have to draw one right triangle. Here the triangle ABC is right triangle in which angle B is the 90 degree. We have to draw perpendicular from the vertex of the right angle, so that from BD is the perpendicular, because in your textbook the name BD given the perpendicular on AC. Let's take right triangle ABC in which angle B is equals to 90 degree and BD perpendicular on AC. Next thing is that we have to prove that triangles on both the sides of perpendicular, means ABD and the BDC, two right triangles on both the sides of perpendicular is the whole triangle, means similar to the triangle ABC and the each other. Triangle ABD similar to ABC, BDC similar to ABC, and both triangles ADB similar to BDC. We have to prove that. So that first of all we have to take one smaller triangle and the triangle ABC. The first is in triangle ABD and triangle ABC. The first of all, see the angle A is common between them. Angle A means angle BAD is equals to angle BAC. Reason is the common angles. The next angle is the right angle in both, because BD is the perpendicular on AC. That's why angle ADB equals to angle, because of both are 90 degree. Therefore the triangle You have to take any name from the ABD. ABD, yeah, ADB, ADB, similar to triangle. A with A, the first is A, next D with B, the next is B, and remaining vertex is C. Because of angle similarity criterion. The first is proved here. It is our result number 1. Now the second thing. Second, we have to take triangle BDC. In triangle BDC and triangle ABC. Same thing is repeated here. Angle C is common between BDC and the ABC. BCD is equals to angle ACB because of common angles. The next 90 degree in both BDC is equals to angle ABC. Both are 90 degree. That's why the triangle BDC is similar to triangle C with C, the last is C, D with B, the middle is B, and the triangle ABC because of angle similarity criterion. It is our result number 2. Now for the third thing. First is completed. First perpendicular the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar. Both triangles ADB and Question is like that. State and prove Pythagoras theorem, or Pythagoras wording in triangle ABC. In right triangle ABC, angle B is equals to 90 degree. The square of the, we need to prove that the square of the hypotenuse is equals to the sum of the squares of another. Then prove that square of AC is equals to AB square plus BC square. The name of triangle can be changed in also examination. Also the triangle PQR, triangle XYZ, triangle DEF mentioned in our question. But question is that prove that in triangle ABC, if angle B is equals to 90 degree, then AC square is equals to AB square plus BC square. For that we have to use our theorem 6.7. First of all, the theorem having 4 parts: given, to prove, figure and the proof. The first of all we have to write here given. It is a part of proof of theorem. Given a triangle ABC in which angle B is equals to 90 degree. Now in to prove, it is the important theorem for our examination. To prove, we have to prove that AC square is equals to AB square plus BC square. The square of hypotenuse is equals to the sum of the squares of another 2 sides. First of all we have to draw one right triangle, because the right triangle is given. You can start from the any one of acute angle in right triangle. Suppose the triangle ABC is here. In your textbook the figure is given like that, but our convenient figure is the vertical triangle. Angle B is 90 degree. It is a right triangle which is given that. The first of all, using theorem 6.7, we have to draw perpendicular BD. The same figure will be repeated here. Let's draw BD on AC. First step of proof. Let's draw BD perpendicular on AC. Then we have to take 2 similar triangles on the sides of perpendicular, both sides of perpendicular similar to ABC. For that, first take ABD, triangle ADB similar to triangle. From this vertex I am going to direction ABC, so that in triangle ADB similarity is ADB. The directions are not required in your proof. It's just for our understanding. ADB similar to triangle ABC. The reason is compulsory because of theorem 6.7. That's why the sides are proportional to each other. Don't take BD, the first take AD. Correspondence to AB is equals to AB correspondence to AC. Reason is compulsory. Sides are proportional. From this statement we have to write like this: AD into AC. By doing cross multiplication, square of AB. It is our result number 1. From the first of all, take ADB similar to ABC. We can't change the similarity between. Order must be changed. Can be ABD. If you haven't taken ABD, then here ACB. But ADB with ACB is a wrong thing. Now we have to take another triangle with direction BDC. Now triangle BDC similar to triangle theorem 6.7. That's why take other than BD means BC correspondence to AC is equals to DC correspondence to BC. Now doing cross multiplication for our convenience, we have to write DC upon BC first. It is not wrong thing, but for our convenience, DC upon BC is equals to BC upon AC. Reason is same, sides are proportional. That's why DC into AC is equals to BC square. It is our result number 2. Now we have to add result number 1 and result number 2. Adding 1 and 2. Result number 1 and result number 2, we have to add left hand side with left hand side and the right hand side with right hand side. AD into AC plus DC into AC is equals to that's why taking AC as a common into bracket AD plus DC is equals to the right hand side remains as it is. Here AC remains as it is. From the figure AD plus DC gives us AC is equals to AB square plus BC square. That's why we know AC into AC comes 2 times in multiplication. Hence proved. Into prove we need AC square is equals to AB square plus BC square. The statement says that in a right triangle the square of the hypotenuse AC square is equals to sum of the squares of another 2 sides, which is AB square plus BC square. Hence the proof of theorem which is most important for our examination. In examination, in 3 ways the question asked. First of all, state and prove Pythagoras theorem. State and prove Pythagoras theorem. Then the statement is compulsory to write in solution of our theorem. Next, prove that in a right triangle the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. In third way, the name of triangle is given. In triangle ABC, angle B is 90 degree. Then prove that AC square is equals to AB square plus BC square. Also, in examination, question will be changed in form of the name of the triangle. In triangle PQR, angle Q is equals to 90 degree. Then prove that PR square is equals to PQ square plus QR square. Name of triangle will be changed also. Now the proof of theorem 6.8 means most important Pythagoras theorem is completed. Now theorem 6.9. Theorem 6.9. Theorem 6.8, converse of Pythagoras theorem. The statement is given. Keep in mind the theorem 6.9 is not in our syllabus, means the proof of this theorem is not in our syllabus, so that we only understood the statement. First given statement is that in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. Or the statement can be written as follow. In a triangle, ABC, AC square is equals to AB square plus BC square, then angle opposite to the first side, means first side is AC, angle B is equals to 90 degree. It is called a converse of Pythagoras theorem. Theorem 6.9 is called converse of Pythagoras theorem. The theorem 6.8 is the most important theorem, so that keep in mind the proof of Pythagoras theorem. One important note, so that keep in mind one important note. On page number 146 in textbook, page number 146, keep in mind one note. Pythagoras theorem was earlier given by Pythagoras theorem was earlier given by an ancient Indian mathematician Bodhayan about 800 BC in the following form. The diagonal of a rectangle produces by itself the same area as produced by its both sides. That is, both sides means, as we know, in a rectangle sides are length and breadth. For this reason, the Pythagoras theorem is sometimes also referred to as the Bodhayan theorem. But in our examination, not taken this theorem as a state and prove Bodhayan theorem, but in examination asked as a state and prove the Pythagoras theorem. But it just for our understanding. The theorem 6.7, the three statement, the first, second and the third. Keep in mind this three statement, how it come. Next, the theorem 6.8 with proof, how the question asked in examination, and the last statement of theorem 6.9, which is converse of Pythagoras theorem. Here the important section of theorem is completed from our textbook. Now whenever we meet in next session, we discuss our example number 10. If you have any query regarding any homework, please tick mark it very well.